Alright, lesson two, fundamentals of axle assemblies. Subcourse OD1006, Edition 6, U.S. wheel vehicles, drivelines, axles, and suspensions. Fundamentals of axles and assembly. Tasks. Describe fundamentals of axle assembly. Conditions. Give information about construction operation, lubrication, maintenance of axles, and assembly type of the principal axle shaft, principal of bevel geared assembly. Differentials. Alright, learning point 1. Describe the types of construction purpose of the axle assembly. The term wheel vehicles mean the vehicles are used to support weight of the vehicle and propel the vehicle with no tracks, runners, or skids. To do this, your top wheels must be secured. The device holds them in position so they can roll and support the load. This device is called an axle. An axle is a cross support between the wheels. The strength, design, and axle's assembly depends on the components thinking of the front axle, you can also see it must support the wheels so they will roll, also turn in differential directions of steering. Now think of the rear axle. If it does not need steering ability, but it does have delivery energy wheels to make the vehicle move. There are two major types of axle. Dead axle used for a front vehicle if the wheels are not powered. Live axle if the rear wheels must be made to rotate. Most commercial trucks are dead axle front end, live axles in the rear. Tactical vehicles use the Army live axles in front and the rear. One exemption of this is the quarter-ton truck, the M151, which uses a separate type of drive with an independent suspension system each wheel. For the civilian cars, the independent suspension system in the front of some of it uses all four wheels. Dead axle. Dead axle used at the front of the trucks do not have front wheel vehicle. They are also used on trailers. They used in front vehicle. They must provide with the steering system used for the trailer. They need to hold the wheels in an upright position. Must be strong enough to support the trailer load. Dead axles are usually held in line with the vehicle frame by springs and support the vehicle load. There are several types of dead axle designs. Alright, figure 8 shows your dead front axle, spindle, and axle. Alright, your I-beam axle. The I-beam axle is made with a high-grade steel forged, proper shape, heat treated. This type of construction produces the axle lightweight, yet the strength of the I-beam axle is shaped with the center part of the several inches below the ends. This permits the body of the vehicle mounted lower than it could be if the axle were straight. Vehicle mounted so that it closer to the road has closer to the road and lower center of gravity and holds the road better. On the top of the axle, the spring is mounted within the flat with a smooth surface of the pad. The mounting surface of the called spring seat usually have 5 holes. 4 holes on the outer edge of the mounting surface of the U-bolts, which hold the spring and the axle together. The center hole provided the anchor point of the center bolt through the spring. The head of the center bolt seated with the center hole of the mounting surface ensure the proper alignment of the axle vehicle frame. A hole is located at the end of each I-beam section. It is bored with a slight angle to provide with the mounting point of the steering knuckle of the kingpin. The small hole of the drill from the front of the rear. The right angle of the steering knuckle pin hole. Enter the large kingpin with the hole very slightly with the kingpin remaining. The bolt is located with the hole and holds the kingpin in place of the axle. Your steering knuckle is made of the yoke at one end of the spindle of the opposite end of the bronze bushing. Press upper and lower arms of the yoke through which the kingpin passes. The bushing will provide with a replaceable bearing surface. Lubricating fitting the drill passage is provided with a method of forcing grease and onto the bearing surface of the bronze bushing. Spindle with a high machine tapered round shaft that has mounting surface of the inner and outer wheels. Bearings, the outer end of the spindle is threaded. The threads are usually installed with a nut to secure the wheel bearings in position. Flange is located between the spindle and the yoke as drilled holes around the outer edge. The flange provided with the mounting surface of the brake drum being backing plate and brake components. Alright, the kingpin acts also like a link to door hinges connection with steering knuckles to end of the axle beam I-beams. The kingpin passes through the upper end of the knuckle yoke through the end of the I-beam of the thrusting bearing, then through the lower arm of the knuckle yoke. Kingpin retaining bolt locks for the pin position. Ball type of the thrust bearing is installed between the I-beam and the lower arm of the knuckle yoke so that the end of the I-beam rests upon the bearing that provides the ball bearing for the knuckle to pivot and supports vehicle weight. Your vehicle is not in motion. The only job the axle is to do is hold the wheel's proper alignment, support with the weight. Part of the weight of the vehicle goes into the motion axle, receive the twisting, stressing, the driving, and braking. The vehicle operates apply with the brakes. Brake shoes are pressed against the moving wheel of the drum. The action tries to make the axle turn. When the vehicle brakes are applied suddenly, the axle twists against the spring and not actually twists out normal upright position. In addition to the twisting during the braking, the fronting of the axle moves upward down as the wheels move out of rough surface. Steering controls linkages provide the means of the turning of the steering knuckles to steer the vehicle as the vehicle is turned while the moving the side thrust of the receiver of the vehicle is transferred over the axle and spring the force of the act on the axle from many different directions. You can see therefore the axle has quite rugged to keep up at all parts of the proper alignment. Trailer axles. Axles used for the truck trailers are designed to mount wheels of the support weight of the vehicle. Since trailer wheels are not powered by the axle used for the all-dead type, large trailer wheels are equipped with surface brakes to assist the stopping. However, hosts the smaller trailer with a single axle, with large ones, normally two axles assembled. The size of the trailer varies from the small 1/4 ton models into large as 50-ton trailer supports. The axle used for the military trailers usually straight, round steel shaft or tube. Smooth machine surfaces at the end of the shaft provide with the mounting of the surface for the wheel bearings. Wheel bearing seals. Threads at the end of the axle shaft hold the wheel bearing retaining nuts. Lock plate with the wheel bearing nuts and fits in the key point way prevent the nuts from working loose. Two steel pads welded with the axle shaft provided seating surfaces to connect the axle with the leaf springs, leaf type springs. Machine flange in the hole, those located around the outer edge, located just inside the wheel bearing surface provided with the bottom of the braking plate, brake backing plate. On semi-trailers with a tandem or two axles, one behind the other, the axles are not usually bolted directly to the leaf-type spring. The springs are mounted on a central trunnion shaft. Spring sheets then aided the holding of the axle and line. Spring ends rest upon the spring of the bearing plates welded to the axle shaft. The tip of the springs can then slide forward and backward on the bearing plate. Torque rods are used to hold the axles in proper position. A trailer axle may support almost all, just part of the total vehicle weight. On small single-axle trailers, most of the weight is supported with the axle. Assembly large semi-trailers are designed so that the towing of the vehicle truck tractor supports much of the load of the trailer assembly. On trailers, brakes controlled by operator towing vehicle axle withstand twisting force. Wheels with the brakes are applied while the motion axle move up and down under the load of the trailer as the wheel flows the surface of the road. With only a few moving parts of the dead axle assembly does not require a large amount of lubrication. Wheel bearings are removed with the assembly pack for the automotive artillery grease or GAA. The intervals required for the lubricating or LO, sealing knuckles, linkages, and front axles lubricated with the automotive artillery grease and means of lubricating fittings. Alright, lesson learning event number 2. Describe the correctional operational live axles and differentials. Major difference between dead and live axles. Live axles can drive each of the wheels mounts of the wheels make a big difference for the construction operation and the cost of the live axles, dead axles. Speed output of the transmission transfer assembly. If it's too fast connected with the private wheels, the wheels connected with the speed will not be enough torque. Put loads in vehicle would also travel entirely too fast. Live axles constructed so that lower speeds and increase the torque and pulling power. This is done by using a reducing gear and small gear driving a lower gear. So figure 9 shows your differential starting from the axle shaft. View the differential drive, ring gear, pinion shaft, pinion gear, and then axle shaft, differential side gear, differential pinion gear, and differential case. Alright, also the axle constructed with the power flow can turn 90 degrees in each direction from the propeller shaft with the right and left wheels. Neither direct the power flow for the drive wheels each side of the vehicle chain, but the direction is done by using worm gear, bevel drive gears. Note if the pinion gear is small, that the ring gear is large. As 2 gears of the reduction speed changing the direction of power flow. Alright, as the vehicle moves around, the turn of the wheel opposite end, the axle must turn at different speeds. The wheel on the outside of the turn travel a large circle on the path. The wheel on the inside turns, then both the wheels rigidly mounted with a solid shaft. Tires would be slide over the road surface vehicle turn a corner. Live axles must therefore include some of the type of the mechanism to prevent wheels from sliding, and the mechanism is called a differential. Permits one wheel to turn faster than the other while still driving both wheels. Output of the differential is transferred wheels by axle shaft. Your type of live axles. Live axles grouped in four general types. They're based on the weight of the load. The support with the easy way to identify the axles, manner of the axle shaft are mounted. Four types are plain, semi-floating, three-quarter floating, and full floating. Each rear the live axle assembly consists of the gearbox, final drive, in the center axle shaft extending from the wheels on either side. Figure 10 shows a plain rear axle. Alright, early vehicles used a live axle known as a plain or non-floating axle. The type of the axle is not used in any modern wheeled vehicle, but the axle reassembled. The semi-floating axle discussed next paragraph. On the outside, however, the axle shaft was supported with the two roller bearings and one roller bearing located just inside the outer end of the axle shaft housing. The outer roller bearing was located in the center axle shaft inside the axle shaft housing. The inner ends of the axle were connected with the differential side gears by key and keyways. These axle shafts had to carry the weight of the differential assembly on either inner ends. Vehicle weight was attached to the outer end of the axle shaft. Therefore, the outer ends of the axle shaft carried the entire weight of the rear of the vehicle. End of thrust of the axle shaft was absorbed and taken up with the ball-type bearing located on each side of the differential case by a block between the inner ends of the axle. Alright, figure 11 shows your semi-floating rear axle. Alright, your semi-floating axle is used on most passenger-light commercial vehicles. The difference between the semi-floating and plain axle is the method of mounting differential assembly support with the axle shaft. The semi-floating axle assembled the different housing is supported in axle housing on the bearings rather than the inner end of the axle shaft. The design relieves the axle for the weight of the sum of the outer operating strength of the differential assembly. The inner ends of the axle or shaft are spline gear differential having only transmit turning effort. The outer ends of the axle shaft mounted with the plain type of the axle of the shafts are supporting vehicle weight, which in wheel side thrust. Outer end of the axle support with a tapered roller bearing. While the type of the construction of the wheel may be come off the vehicle if the shaft should break. This is all true for plain axle above. Alright, figure 12, the three-quarter floating rear axle. Your three-quarter floating rear axle, three-quarter floating axle, also used in some of the earlier commercial vehicles with the bearing support outer end of the axle shaft. Move the inside axle housing to the outside of the method of mounting axles, placed over the weight, most of the weight of the vehicle end of the axle housing rather than end of the axle shaft. The wheel is solidly keyed and tapered at the end of the axle shaft. Side thrust is still taken by the axle shaft. Vehicle turns or skids. Figure 13, the full floating rear axle. Your fourth type of the axle is known as the full floating type of the axle. The type of the axle used with the military and tactical wheeled vehicles. Major difference between the three-quarter and full floating axles and two bearings used for the mounting of the wheel of the axle housing instead of the one bearing. With this method, the construction axle should be removed without disturbing the wheel differential assembly. Axle shaft with the full floating assembly with the flange outer end of the flange connects to the axle shaft with the hub of the wheel with the flange. That axle shaft drive the wheels on rear axle. Flange is part of the axle shaft. On the fore axle, the end of the shaft is spline with the spline flanges inside over the end of the shaft is bolted in the wheel hub. Your final drive gear. The final drive gear is most important for the powertrain between the propeller shaft and the differential part of the axle. Assembly provide the 90% degree change in direction of power flow, increase the torque and the turning force. Final drives in most military tactical vehicles are either single or double the reduction units. Single reduction are used in light wheel vehicles, consist of one set of the reduction gears, and the same gears are changed with the direction of power flow with a double the reaction. The units of the second set of the reduction gears. Double reduction final drives are used when they heavy wheel vehicles. Large amount reduction is needed. So, figure 14 shows a worm gear. Some early vehicles built with the heavy loads with the worm gear final drive. The type of the gearing provided with a large amount of the reduction work. While heavy, slowing, moving the trucks. So the gear consists of the worm and a worm gear. The type of the gear creates a lot of friction between the gear and the end of the worm. This is not adaptable with the high-speed operation of modern vehicles. Alright, figure 15 shows a spur bevel gear. Second type of the gear of the cabine with the final drive of the live axles of the bevel gear. Like a worm gear, bevel gears use the chain with the direction power flow. Also provide with the reduction bevel gears. The drive gears are sometimes called arm or two different general types. One type of the straight teeth is known as the spur bevel gear, and the other type of with the teeth locked look twisted. This is called a spiral bevel gear. Bevel gears finally drive with a live axle consisting of two gears smaller called the pinion. Is connected to the propeller shaft with larger gears. Looks like a ring and with the teeth cut in on an angle on the side of the ring gear. Your spur bevel gear finally drives usually with the early vehicle that knows you well. We're not strong enough with the meshing with the gears, only one tooth of the contact with the characteristics of all support of spur gears. Twisting of the teeth of the spur gear. Contact surface of the gear teeth is made longer more than one tooth of the contact at one time. Therefore, spiral bevel gears are then they are called eventually replace spur gears and live axle because they are stronger and quieter. The pinion connected with the propeller shaft while the ring gear drive the axle through the differential case and gearing. Alright, figure 16 shows your spiral hypoid gear, spiral bevel gear, and then your hypoid gear. It was found that by lowering the pinion and the center line with the bevel ring gear, that the teeth mesh could be no longer. That meant the gear set would be still stronger than the spiral bevel set. Is a lot lowered propeller shaft now it allowed the vehicle body to be lowered. Improved versions of spiral bevel gear is known as the hypoid gear. Hypoid gearing. It is used with the commercial and military vehicle. The pinion ring gear are both mounted with the same type of the bearings. The spiral bevel gearing. The pinions move above below the ring gear center line compared with the illustration of spring bevel gears and hypoid gears. Alright, gear ratios. The size of the gears used with the final driver depends on the need of the vehicle. The relationship with the pinion of the ring gear is known as the gear ratio. The ratio of the gear is obtained by the divide of the number of the teeth of the pinion by the number of teeth on the ring gear. This will show that many revolutions of the pinion makes of the ring gear makes one revolution. For example, the pinion has 10 teeth, the ring gear has 50 teeth. The ring gear has 5 times as many teeth, the ratio of 5 to 1. Ratio of automobile drive axles range from 2.5 to 1 to 5 to 1. Large trucks have a gear ratio ranging from 5 to 1 to 15 to 1. Lighter vehicles are not required to have heavy loads and even the comparable lower ratio set gears. For example, the small commercial trucks may have a gear within ratio of 5 to 1. The ratio can be easily obtained with one set of the reduction gears. Large trucks need gear ratios up to 15 to 1, where the would mean that 10 teeth were pinion, while it would be the 150 teeth on the ring gear. The ring gear with the side of the would take up much of the room inside of instead of the ratio total production divided up between two sets of the reduction gear. The type of the gear arrangement is known as the double reduction drive. This way, the bevel gear supply will be 3 to 1 reduction, while the second reduction gear gives a 5 to 1 reduction. Overall ratio would be 15 to 1, and none of the gears would be taken out of too much room. Your double reduction axle should be not confused with a 2-speed axle. Some of the commercial trucks have the drive axle 2 different ratio reductions. The driver can select a ratio needed with the control of the located on the truck cab. The type of the axle has a low range, high range. The ranges are actually 2 different ratio reduction 2-speed axles known as a dual ratio or double reduction dual ratio axles. Our differential. One live axle for the wheel must different speed with the other vehicle goes around the corner. Additional gears is required with the a lot of difference in speed with the wheels. The gearing must also continue to both drive between wheels, but at the same time, gearing some of the design of the job is called the differential. Differential assembly is mounted with the axle housing as bolt of the driving with the final ring drive gear. Your differential case consists of the shield casting bolted together with a single solid unit. The right and left ends of the machine provided with the mounting of the tapered roller bearing. With the roller bearing support the entire drive assembly with the axle housing. Differential rotates same direction wheel of the tires. Axle shaft enters the drive assembly with the right and left side. The ring gear final drive is bolted and riveted mounting flange of the drive case. So figure 17 shows your gears, your differential case, your hypoid driven gear, your pin shaft roller bearings, your differential carrier, and hypoid drive gear. Alright, then it shows a split screen of the differential starting at the axle shaft, sliding gear, dog clutch, controller lever clutch, planetary gear, 2 propeller shaft, oil seal, outer driving, pinion gearing, in-ear driver, pinion gear, differential case, truss washer, differential side gear, differential pinion, spider trunnion, bevel gear, drive, internal gear, ring-on drive case, sun gear, bearing adjusting ring, and then axle shaft again. As the drawing shows what the differential looks like, notice the holes of the two halves of the case were in the forestem of the spire can. See the two halves of the case for the bolt together. The spire and cross shaft of the place of the ring gear is bolted in the place of the left half of the case. The entire unit must have the rotate ring gear turns. Also notice there as a bearing strip of the two sides of the case to support the machine shoulders and bevel-sided gears. Alright, some light vehicles use only a two-spire pinion with the differential with a straight shaft instead of the four-fingered spider support with the spire pinions. Sometimes remember these side gears are free turning of the or bearing surface with the end of the spire pinion, also free turning of the spire cross shaft. Shows your side gears, conventional differential pinion side gears, and then your high traction differential pinion side gears. Alright, two differential gearing is used for the center axle assembly with dimensional design to deliver equal twisting effort with the torque. To example, all times of the high traction delivery valve torque each side of the gear depending on the direction of the wheels. Note the conventional design of the teeth of the spire pinion are placed on each other. Alright, also teeth of the normal spur gear tooth shape. There's one tooth that comes out of the bench of the one side of the gear. The tooth of the opposite side is the same thing. Look at the shape of the type of the high traction gear with the ring gear with the forcing the unit with the rotate spire pinion moving down. Two teeth would be forcing the side of the gear axle shaft wheel to rotate. However, look at the difference with the point of the contact with the two teeth with the leverage of the center of the spire with the point of the contact tooth is much longer than for the one tooth. And then recall principal gear with the arrangement with the ply with the greater force of the second tooth. Your high traction type gearing works as well with a very open, only a small amount of wheel slippage is involved. However, the one wheel large P with the ice other wheel has good traction. It will not be provided enough changing the torque to keep one wheel from the spinning. Rear axle. Axle shaft must be strong enough to provide delivery twice the force necessary to move the vehicle under all conditions. Floating axle shaft spline at one end of the splines differential side gear. The other end contains a flange that can be bolted to the wheel hub or maybe spline and requires spline flange that slides into the shaft first and then bolted into the hub. Semi-floating axles are mounted a little different. Remember, they support some of the vehicle weight of the vehicle, so the wheel is tapered and wheel head is keyed into and held in place with the axle nut. Alright, axle housing, usually steel casting varies size according to the vehicle, depending on the size of the lower housing mounts and wheel axle shaft final driven. Differential assembly seats, a flat surface that provide either the top or the bottom of the housing. Four springs, one vehicle, more than one rear axle. Torque rods are connected to the arms located on the top of the bottom of the housing. Like tandem trailer axles, the torque on the rod and leaf springs keep the axle in position. Or one type of axle housing used for the wheel vehicle. For some of the early vehicles that used an axle housing made of the two sections consisting of the right and left section where joined with the center of the bolts. Axle used for the type of the housing are called split type. The split construction required with the axle removed the first and then complete with the disassembly for inspection and repair. Differential. The standard type of the differential assembly is supported with the tapered roller bearings in the right and left housing. The drive pinion shaft are mounted with the front and the rear left of the section. Most present-day vehicle with the banjo type of the rear axle with the type of the construction of the differential final rear assembly is made with a single unit axle housing, large single unit with a large option center receiver. The differential assembly with the differential final drive bolted in the front of the housing axle shaft itself with the right and left end. If possible, to remove the repair of the differential without completing disassembly with the axle assembly. Two different banjo type of the axles are presented usually in military wheeled vehicles. One type mount final drive assembly front of the rear of the housing. Second type of the banjo axle mount of the final drive gear on the top of the axle housing. This type of the axle is mounted on most of the military tandem axle truss and is used for the front steering and the drive axles as well with both rear driving axles on military vehicle type of the axle for bubble reduction final driving gear. Alright, operation live rear axles. As the vehicle operates, engage the clutch, rotating the motion of the engine, transmit the transmission, transfer cable, the axle, the propeller shaft of the transmission, the propeller shaft with the pinion shaft with the knee with the flange and yoke at the end of the front axle, turn the pinion shaft gear with the final drive, with the forcing of the ring gear with the mesh for the pinion gear with the turning in the direction driven by the pinions. Since the ring gear has more teeth, the pinion is rotated more slowly. This is therefore loss of speed gain of the torque between the pinion and ring gear. Ring gear is solidly fastened to the differential cable, therefore the entire differential assembly turned to the gear turns. Spider differential pinion shaft that are mounted to the carry, so the carried along with the same speed as case. The vehicles mounted with a straight ahead with a smooth surface with the differential portion that do not rotate with the spider or cross shaft. If the pinion is carried along with the differential cave of the drive with the two-side gear for the same speed as the case. Each side receive the same amount of torque. The right and left axle spline with the differential side gear with the driven with the same speed of the returning differential assembly. The outer end of the two axle drive vehicles are at the same speed. Let's say the vehicle goes around a short right turn. Notice that the center of the rear axle has been given the distance for the turning. The two wheels have two different distances. The outer wheel has almost 4 extra feet to keep up with the inner wheel. This means the outer wheel has traveled faster for the inner wheel to the travel the greater distance. This also means the differential side gear travel two different speeds. So the center line and center rotation, knuckle pivot, and center rotation. When the differential side gear rotates with the two differential speed with the cause of the pinion speed gear with the rotate their shaft, with the pinion walks around with the slower side gear with the force of the other side with the two faster or speed up. Faster side gear must return the speed of the final driven gear with the whatever rotation is being caught with the rotating pinion. Pinion rotate with the travel between the two side gear with the pinion continues to rotate on their shaft as long as the side gear with the different speed of the vehicle with the turns the opposite direction. Pinion will rotate on the shaft with both operating opposite directions. The inner wheel slows down with the turn of the outer wheel speeds the same amount. For example, the stay of the ring over the ring gear differential case rotating at 103 revolutions per minute of the vehicle makes the turn and the inside of the wheel to slow down to 70 RPMs. This is the 380 RPM slower with the ring gear. The outer wheel therefore has two rotating at 30 RPMs faster with the ring gear at 130 RPMs. If the torquing was being applied with the rear axle as when going up the hill with the torque engine for the rear axle, through the pinion and creep of the passive, through the ring gear, will then transfer the differential case, the differential pinion shaft pinion, but the pinions are and apply equally torque to axle side gear with the torque of the transfer within the wheels of the axle shaft. If turning on one side of the axle with the conventional differential off with the grip of the road, the surface of the wheel will spin with the traction of the grip of the road gone on one side of the wheel, become with a very easy to turn. Opposite wheel still has good traction and hard to turn with the power flow, takes the path of leak resistance, goes into slipping wheel because of the differential gauging one side of the gear, hard turn with the other, very easy. The differential pinion with the walk around the harder turn side gear at the same time, and the easy turn side gear faster than normal. This is an undesirable feature that is enough problem to cover the change of the type of the axle used on some vehicles. Great amount of force is needed to move the heavy vehicle when stopped. When the engine torque is applied with the rear axle, the force attempting to move it in many directions has been geared tight and to try to turn the ring gear. Two gears will be tended to force apart. Keeping in mind when the engine tries to move the vehicle and the vehicle will resist and try to remain at rest. Pinion gear of the drive gear is straight bevel type of the force being applied will try to push the driving pinion to the front of the vehicle. To the side of the way of the ring gear, spiral bevel pinion may be pulled inward toward the differential to drive of the ring gear. At the same time, the ring gear will try to move the side away from the driving pin. Some axle assemblies include the thrust pad mounted with the cave of the rear of the ring gear to limit the amount of the gear car and move the sideways. If the ring gear is forced away from the pinion, the twisting forces receive the differential carrier bearings of the ring gear drive the differential resistance of the wheels, causing assembly to drive against the promoting bearings inside of the cave of the differential gears trying to push themselves apart as torque applied. In this case, both pinions and side gears press against the thrust washer between the gear and the case. When suddenly heavy with the force applied with the axle shaft tending and twisting and winding up, the entire axle assembly twists and mounting springs the drive wheel with the vehicle springs and torque rods designed to control the twisting of the axle assembly. Our construction of live front axles, one of the requirements of the tactical military vehicle, the all-wheel vehicle with the drive, provided the front axle most of it to be similar to the rear axle assembly. The main difference between live front and live rear axles is that the front wheels must be able to pivot the steering for the purposes of the SME, but the driving axle shaft must be able to deliver torque at the angle of the wheels when they are turned. The very little difference of the final drive and the differential assembly on most of the front and rear live axles. Some of the model vehicle, the differential assemblies are made both same in the front and rear. That may be the interchange. The section, therefore, will construct the parts now found in the rear axle. The axle housing, large steel hollow casting, acts for the base of the mounting of all the other parts of the front axle housing. Final drive differential assembly off the mounting and off center of this allow the driving propeller shaft passed by the engine oil pan. Axle housing extended on the way all the way to cover the front of the rear of the vehicle. Each end of the housing containing the components of the steering mechanism and the dead axle that is as part of the axle hinge, providing steering point on the live axle. The steering knuckle appears with a large ball joint with each end of the axle housing shaped like a ball. From the top of the bottom of the round end of the housing containing the mounting parts of the spindle knuckle bearing the round of the outside of the partly covering part of the round end of the axle housing of the steering knuckle housing. Steering knuckle housing is connected to the end of the housing of the upper and lower knuckle bearings. On the top of the axle, the kingpin cannot be held by the bearings in position because it cannot pass completely through the housing of the live axle. Two short kingpins are either the top of the bottom at each end of the axle to align with the bearing. The kingpins may be mounted with the axle housing on the plate with bolts on top of the bottom of the steering knuckle housing. Your tapered roller bearings help support the vehicle with the kept the steering knuckle within proper alignment. The bearings also provide the pivot and turning of the steering wheel. Shims give the bearing mounting surface to ensure the proper assignment adjustment. An oil-sealed mounting of the inner side of the steering knuckle housing rides with the brown with the surface of the extent of the axle housing spindle as the flange of the bolts outside of the steering knuckle housing, and the spindle also serves as the mounting point of the wheel hub and the bearings. Our constant velocity joints, or CV joints, the axle shall operate with a hollow tube section at each end of the axle housing. The inner end of the axle shaft is spine with a side gear with a differential assembly. One of the most tactical military vehicles, outer end of the axle shaft is splined to a flange. This flange is both the wheel hub provided the means of the driving the front wheel. Your front axles must be able to pivot the steering knuckle. They must be able to universal to transmit power at an angle. The single conventional universal joint typical type used of the propeller shaft does not meet military requirements for use of the front axle assembly. During steering the axle shaft, the front live axle assembly must operate at angles up to 30 degrees and has drive output with the same input without speed changes. The type of the type of used on military vehicles is called the constant velocity joint. There are three types of constant velocity joints used in the military. They are the Rizeppa, the Bendix, Wise, and the Tracta. Alright, the Rizeppa constant velocity show that your plane driving line gauge and outer rear driving ball, inner race, the axle shaft, three angle equal, and then it shows your axle. Rizeppa type of joint, 6 smooth steel balls provide with a flexible drive. These balls are mounted between the inner and outer races. Outer races made part of the outer axle shaft of the inner races, separate spare parts spline with the outside and inside axle. A cage is made to fit around the axle. The 6 driving bolts hold in the proper position of the vehicle. Turn the pivot and pilot spring with the pinion mounted on the constant velocity joint to control moving the cage balls. And it shows the cage Blendix constant velocity joint. Alright, your Bendix Wise joint, also steel ball, transmit power angle with a slightly with differential construction. Notice with the illustration, both inner and outer axle shaft has yokes at the part of the shaft. Yokes contain the race of smooth steel ball with the race to the groove with the permit with the ball with the move back and forth with the drive. The angle of the shaft changes. There are 4 balls mounted with the 2 yokes and with the race of the 5th ball mounted with the center lock with the 4 outer balls at the place. The center ball is held in place with a pin. The joint is assembled with the steel balls forming a tight fit between the inner and outer shaft. The tight fit is necessary since there is no cage to hold the balls out. Movement is controlled with the friction between the connection of the parts. Alright, and then it shows your Tracta constant velocity joint. The Tracta type constant velocity is not like other types since no steel balls are used to provide flexible driving in place. Over the balls, 2-ton groove portions mounted between the inner and outer shaft. 2-point portions or halves are called the universal joints. A universal joint. 2 halves of the universal joint are made with the male and female to fit together with a floating movable connection. Each 2 center portions are made with a mounted on an axle shaft yoke. Yoke of the inner end of each of the shaft provides a floating connection with a constant velocity joint. When assembled, each of the 2 center portions they able to pivot and turn between the other portion connecting axle with the actual shaft with the support of the housing and bushing on each side of the constant velocity joint. Alright, operation or live axles. The operation of the final drive of the differential assemble the live from front axle, same with the rear axle gear ratio to increase the engine torque with the same as over the rear axle. Some of the front axle assembly using vehicles are designed to operate with under power of all time. Some vehicles have control within the cab permitted for the driver to engage the front axle when it's needed. Other vehicles have the devices made to transfer assembly automatically engage front wheel drive with the rear tires with the loose traction spinning. While the vehicle is traveling straight ahead of the inner and outer axle shaft, they're on the same line with the front engine gauge axle is engaged on powertrain. The inner axle shaft with the drive with a constant velocity joint. Constant velocity joint will drive the outer axle shaft, which are splined with the wheel hubs and steering arms, rods, and turn knuckles. Axle shafts will flex the constant velocity joint. During the turns, the constant velocity joint will continue to deliver smooth, steady flow of the torque. Steering linkages, both steering knuckles at the same time, proper angle of the turn. Alright, lubricating of the live axles. Whenever the vehicle is moving the gear with the final drive with the differential or turning lower part of the gearbox is filled with the gear and oil of the required level lower part of the all gearing passes the pool each oil each time unit rotates, thereby lubricating all working parts. Some type of axle assembly flows down each of the shaft of the housing can lubricate the bearings and support outer ends of the axle shaft of the wheel bearings. Lubricate the constant velocity joint, generally done with a packing joint with a grease, automotive, and artillery. Your breathe valves are installed with the axle assembly to allow the excess pressure escape. Pressure will build up if the gearbox as the units heat up during the operation. Breather valve must be able to perform job without allowing dirt and water to enter from the outside. Her drive axle high mobility multi-purpose wheel vehicle. The 1 1/4 ton utility truck, the M998 series, the final drive of the differential for the outer vehicle with each of the truck models equipped with the individual independent with wheel suspension. This means each wheel has its own separate mounting, not solidly connected to enter for the other wheels. Each of the wheels move up and down on the vehicle of the road surface without affecting the other wheels. This type of construction does away with the solid axle to the extent of the across the vehicle with the below of the body of the frame. The differential assembly made with a separate unit, both the front and rear differential axles, so it's unmounted with the frame of the vehicle rather than the axle housing. Your high mobility command vehicles use axle drive half shafts accommodated with the independent suspension. Purpose of the half shaft, the transfer torque wheel with the differential through a geared hub. Usually, basically one piece assembly, while the boots of both the inboard differential outer board geared hub ends. Inboard and bolted with the differential side flames outboard, end of the spline drive gear with the gear hub, inboard boot and cage enclosed with the triple tripod joint, which accommodates the in and out angular motion of the axle drive shaft with no change to either system. The outer boot and get enclosed with the constant velocity joint with the transmit with the torque through the various steering angles of the gear hub. Constant velocity joint ends of the shaft assembly held in place with the axle shaft, the retaining bolt located opposite of the pipe plug with a geared housing, tripod housing affecting plate with both differential output flange bolts and caliper mounting brackets. The geared hub in the gearbox located with the wheel end surface of the front wheel with a spindle with a conservative final drill of units, perhaps up to 16 inches of the ground clearance. The geared hub included with the drive gear with the driving gear enclosed with the housing. The driver gear is turned with the differential half speed, half shaft powers, and the driving gear with the turns of wheel spindle. Geared hub is joined with the upper and lower control arm by ball joints bolted to the outer end of each of the arm. Driving gear splined with the wheels and supplied with the drive gear is turned with the differential driving half shaft. The radius arm and the cover of the steering arm and cover is connected with the center ball by the tie rod. Alright, learning event 3. Describe inspections of the back up to the top here. Reading it in parts. Learning event number 3. Describe the inspection procedure of the axle assembly. With the vehicle is going to go over the tore-off treatment whenever the vehicle moves over the uneven surface. Military tactical wheels are travel across country, which will have the inspect the actual quiet with the differential same troubles with it. Develop with a big trouble. There are 2 major types of the axle arrangements will work with the independent suspension solid housing type. Inspection procedure for all the solid type is the same, with the procedure independent suspension type differ. The axles must be inspected with the surface properly if they are due their job properly. Faults are such loose bolts of the cracked housing, leaking seal, to other minor troubles eventually lead to major repair job that is not corrected as soon as possible. If the minor repairs are not made with the first need, the vehicle can very well have evacuated the higher level of maintenance at a later day. Lesson will cover the maintenance procedure for the inspecting fore and rear axle assembly, all axle components of the M151 and 1/4 ton truck, 2.5 ton 6x6 trucks. Inspecting procedure. The first type of the axle will discover that is over the 2.5 ton M35A2 with the trucks, 1 driving in front with the axle with the 2 driving the rear axle. Axle with the top mount with the double production single speed type. 2 rear axles assembly with exactly like the front axles similar but contains additional components that allow the front and rear wheels to pivot the steer of the truck. Rear axle inspection M35A2. When you inspect the rear axle of the assembly of the 2.5 ton M35A2, use the following guidelines. Take a look at the axle assembly. Can you see anything that would make the axle assembly unserviceable? Use the lug wrench. Check all lug nuts are tight. Check all the other nuts and screws to make sure they are present and tight. Check with the spring guide bracket, the torque rod bracket, the condition of the securing, the mounting. Check with the different leaks and seals and gaskets. Check for plug, the leaking housing vents. Check for loose damaged companion flanges with the proper shaft that's attached to the differential. Check with the tube level of the differential. Check with the broken axle shaft. First, block all the wheels and not check for the jack up of the wheel with the driven shaft should be checked. Put the transmission transfer case in the gear, trying to determine the wheel. If the wheel turns without turning the propeller shaft of the axle is broken with the differential and is unserviced. Check all areas of the axle assembly with leaking brake fluid or lubricant. Check the wheel bearing adjustment with the wheel bearings adjusting properly. Slightly movement between the brake drum and the braking plate will be found. The wheels must be jacked up for each check. Check the entire assembly with the excessive dirt and damage that may be road tested for the vehicle. This listen excessive for the unusual noise of both front and rear axles. Front axle inspection, the M35A2. Inspect the front axle and the 2.5 ton M35A2. Make all the checks made with the rear axle plus the check with the steering system. Check for the bent and damaged steering components. Examine the tires' excessive wear due to the analysis aligned with the axle during steering components. Before you make a toe-in check of adjustment, the wheel bearings must be properly adjusted. The tire must be inflated. The correct pressure of the vehicle must be on smooth, level surface of the wheel, straight ahead position. The two methods of it you can use to check the toe-in of the M35A2 truck. Place the toe-in gauge between the first tires ahead of the axle end of the place against the tire sidewall. The bolt chains must have the same distance for the floor. Make sure the gauge of the post properly positioned at each wheel. So the gauge so the points is measured the gear of the move the forward and truck forward and some still change the same distance of the floor of the back of the axle there with all in the front. The pointer will now show amount of the wheels and if they either towed in or towed out front. Correct thing is 1/16, 3/16 of an inch closer in the front, but then the back of the wheels of the 9 by 20 tires. Second method, the consisting making with a scribe mark with the center line with the front axle with the tire with the same height with the floor of the center over the axle, and using steel tape to measure the distance between the two parts. Then roll the vehicle forward and the parts of the same distance with the floor as they were in the front. Measure the distance between them. Make the necessary adjustments to ride, bringing and towing the proper amount. Inspection of the M151 series truck axles. The vehicle has front and back drive assembly bolted in the frame rail, swinging axles to the wheels. Inspect the drive assembly for the following as guides. Check differential and screw mounting, leaking seal of the gaskets, damaged drive seal, side gear flanges. Check with the breather valve located at the top of the differential. Check with the wheel drive shaft, the universal joints of wear damage, and proper mounting. Slip joint end should be connected with the differential. Check with the wheel flange, driving gauge, spindle hub with the damage and screw mounting. Jump road test the vehicle with listen and excessive unusual noise, both the front and rear drive assemblies. When you inspect the front drive assembly of the M151 truck, use the same procedure used on the rear. In addition, inspect all the ball joints, serviceability, and examine all the tires, excessive wear of the misalignment steering components. Use the same procedure for the 2.5 ton of the M35A2 to check with the toe-in on the M51 truck. The toe-in on the M51 should be centered with the steering wheel approximately 1 5/16 of the turn back from the stop. One spoke with the steering wheel should be in the line with the center of the steering column. This is straight ahead position. The toe-in setting is 1/32 to 5/32 of an inch. Then show the practice exercise and intended page left blank, the answers, and then it moves into lesson 3, fundamentals of suspension systems.